to Lab Tutorials of Digital Design and Computer Organization. I am Sahana Aris, Assistant Professor, Department of Information Science and Engineering, Rajiv Institute of Technology, Hassan. We shall discuss about the first experiment, that is, given a 4-variable logic expression, simplify it using appropriate technique and simulate the same using basic gates. We need to consider an expression of a 4-variable, and then we need to use K-map or using algebraic manipulation to reduce the given equation, and then we have to implement this using basic gates, and we need to simulate it using BCS302. So let us see the first experiment. This is the equation. Consider here A, B, C, D are my 4 variables, and this is the expression of that 4 variables. Here the given expression has to be converted to minterms. The conversion of expression to minterms is given in this table. So each and every Boolean expression has equivalent minterms, that is equal. Here we are having 4 variable input, then that means we have to consider 4 variable K-map for the given expression, and we need to mark all these minterms in the K-map, and we have to group them and reduce the given equation to a simpler form. So the K-map is shown here. The detailed K-map is as shown here. K-map can be clearly understood by observing this figure. Okay, we have to group in the terms of 2 power n. We can group 8 minterms together, or 4 minterms, or 2 minterms together, or individually we can consider 1 minterms for the equation. Okay, in the given equation, if we group the minterms, the K-map will look as shown in the figure. For this, the derived equation will be f of a comma b comma c comma d is equal to b dash c dash d dash plus a dash b dash c plus a b d plus b c. Now let us try to implement this equation using piecewise and simulate the same. Given expression is as shown here. We need 4 NOT gate, 3 input AND gate, and 1 2 input AND gate. Next we require 3 2 input OR gate. Okay, now let us try to implement this in piecewise and let us simulate the output. So to implement, double click on capture light, go to file, new project, give a project name, click on OK. Okay, then create a blank project. Okay, so now observe this circuit and implement the same in piecewise. Okay, observe here we require 4 NOT gate, 3 input NOT AND gate, 1 2 input AND gate. Just first you select all the gates, place there, then you can connect it. Okay, go to place part. 7432 is our OR gate. Select. We require 3 OR gate. Place them. Okay, end module. Then go to place part. 7411. 7411 is our 3 input AND gate. Okay, we require 3 input AND gate. Place them. End mode. Then go to place part. We require 1 2 input AND gate. 7408 is an IC number. Click on OK. Then place 1 2 input AND gate. Okay. After placing this, then we require is AND gate. NOT gate. Go to place part. 7404 is the IC number for NOT gate. Select OK. Then you can observe here the NOT gate is in the form of it is somewhat rotated. So to place the NOT gate in like this, you go to place, select NOT gate, okay, rotate, then you can place it. We require 4 NOT gate, place 4 NOT gates, okay, end. Okay, the output coming, the input given to NOT gate will be A, B, C and D. The output coming out of the NOT gate is A dash, B dash, C dash and D dash. Okay, you can draw lines. Let's try to connect these inputs and outputs. So draw a wire. This line represents NOT of the input. Okay, whatever may be the input you have given, this lines represents NOT of the input given. Then this represents the input. Up to the equation, first we have is B dash, C dash and D dash. Okay. If you get it confused, first label it. This is considered as A, B, C and D. If you want, you can name it using place that alias A. This is A. Next we have is B. Up to leveling. So first 3 input AND gate has input B dash, C dash and D dash. Try to join. This is our B dash. Okay. First input is given to B dash. Next is C dash. The first input has to be given to B dash. Next C dash. Next D dash. Okay, all the 3 inputs are connected. Next, check for second AND gate. The second AND gate input is A dash, B dash and C dash. A dash, B dash and C dash. Okay. Next is input ABC. A, B and C. Next we have is B, and C. Then connect this 2 AND gate output to 1 OR gate. Okay. The output from this will be our F. Give name for your output, consider it as F, place it, enter. Now we have to give an input, place part digital clock. Rotate it and place for A, B, C and D. Okay, 4 inputs has to be placed. Try to connect them using wire. Now give the off time and on time. For first input, 8 will be the on time and off time. For second, 4 off time and 4 on time. For the third input, 2 on time and 2 off time. For the last, 1 on time and 1 off time. Now click on paste space, new simulation, give the name of a simulation, experiment 1, create, run time as 20 microseconds, step as 1 microseconds, click on OK. Now run the program. Okay, go to trace, add traces. You need to select all the 4 inputs and 1 output. Okay. To get to know whether the implementation is right or wrong, observe this truth table. Okay, this is the output for equation F that you have derived. Okay. For the combination 3, for all the 4 combination is equal to 0, the output has to be 1. Okay. For all 3, that means A is equal to 0, B equal to 0, C is equal to 0 and D is equal to 0, the output is 1. Okay, similarly check for other condition. For 101, for 1010 combination, okay, for the 1010 combination, the output is 0. You can observe the output is 0. Similarly, verify for all the 16 input combination and check if the simulation is right or wrong. This is all about the first experiment. Okay, this is the circuit that you have to draw it, and this is the waveform you will get after designing it. Thank you.